Good morning. We are the Crow Wing County Got Guts team. My name's Madeline.
I'm Amelia Henricks.
I'm Simon Nelson.
I'm Erica Kahi.
We are all from Dagerbrook 4-H Club south of Brainerd. In today's presentation, we will be defining a problem, problem analysis, going over some history and science of anaerobic digestion, budget and business, biogas systems to consider, and recommendations and the next steps. Our defined problem is assessing anaerobic digestion as a means to create energy while using poultry offal as a fuel source at a small farm poultry processing plant. Some terminology we would like you to know for this presentation is offal. It's chicken material left over from poultry processing that's not food. Volatility, the measure of variation in price. Slurry, it's the material inside the anaerobic digester that are liquids and solids. Anaerobic digestion, a process where bacteria break down organic matter, such as manure or poultry offal, in the absence of oxygen. And digestate, after the gas is captured, this is the end result of the waste, and it is the rocket fuel of all fertilizers. We have a joke for you today. Why did the chicken cross the road? Simon?
Because he had an awful day. My parents, Ron and Barb Nelson, started Nelson Shine Produce in 2004. They originally milked cows in our dairy barn, but saw an opportunity when one of our neighbors was selling some processing equipment. We started with a few hundred birds the first year, but people started coming from all over the state of Minnesota, so we built a processing building. Business grew rapidly over the years. We currently process about 60,000 birds a year. Our customers bring live birds to be slaughtered. We sanitarily slaughter, clean, package, and freeze them in our building. I am the youngest of 7. We have all worked and helped in the building. My favorite job is packaging or hauling out the chicken offal.
We are all related to Nelson Shine Produce in some way. Me and Amelia work there, Simon lives there, and Erica brings her family's birds there each year to get processed.
The business owner has helped us analyze the following points. The farm needs to continue to actively manage its poultry offal, cost of energy, fertilizer currently isn't being used to its full potential, and currently the operation allows the methane to go into the atmosphere.
Nelson Shine Produce needs to efficiently manage their offal. We want it so that the customers is appealing to the customers, there is no smell, and there's no flies.
Nelson Shine Produce runs our operation on electricity and propane. About 10 years ago, the prices for propane increased. Electricity costs were increasing in the early 2000s, but then remained steady for about 5 years. At the end of 2013, prices increased again. The cost is forecasted to remain stable throughout 2015, but the problem here is the potential for volatility in the cost. This chart shows on the left side the cents per kilowatt hour. You can see it's unstable but steadily going up, and on the right side the annual growth in percentage.
Nelson Shine Produce needs to continue to use the poultry offal as fertilizer in the farming operation. A methane digester would allow the methane to be used as energy. The poultry offal digestate would stay on the farm to be used as fertilizer in the farming operation.
Currently, Nelson Shine Produce composts their offal in a compost pile. The methane is going up into the atmosphere, and we strongly feel that global warming needs to be solved.
Some brief history about anaerobic digestion is it has been around in India since the early 1800s and China since the early 1900s. Anaerobic digestion didn't really become popular until the government became involved in those countries. Anaerobic digestion is now common in European countries, China, India, Vietnam, and Central and South America.
Our team attempted to make methane using a 2-liter bottle with the balloon on the spout of the bottle. We left it in a chamber for 7 days at a temperature of 100 degrees Fahrenheit. It was exciting because the balloon got bigger and bigger right away, but then corroded at the top from the latex in the balloons. We were disappointed after 3 failed attempts. We just learned that bacteria comes before methane in the digesting process and decided to learn more about anaerobic digestion. We learned that there is a lot of research out there about it, but more about dairy manure instead of poultry offal. This is a picture of our team with our two main coaches. On the right is Jim Chamberlain. He connected us with scientific researchers. And Ron Nelson in the middle, he is a small farm successful business owner and has opened up his business to us and has been very excited with this effort.
And speaking of science experts, we also consulted with Hunt Utilities Group in Pine River, Minnesota. Hunt Utilities conducts research on reducing our need for carbon-based fuels. Ryan Hunt and a bunch of other science geeks advised us on a presentation we gave to them on June 4th.
Also, consulted with Professor Bill Lazarus of the U of M Department of Applied Economics, expert in methane digesters and applications on the farm. We presented to him June 11th.
This is a model of a methane molecule. It has one atom carbon, 4 atoms hydrogen. It has a greater effect on the atmosphere than carbon dioxide. The methane that comes out of the anaerobic digester, we would use in our scalder in our building. A scalder is a big heated tub full of water. It spins the chickens around it for about a minute, and it loosens the feathers on the bird. It is one of our most important machines in the building. We would switch out the propane for the methane. We could also build a generator, and the methane would go into the generator, and the generator would produce electricity, which that would heat the building, or not, heat the scalder. This is an overall layout of the plant. The chicken offal will come out of the building and go into the digester. The solids and liquids will go into a dewatering system where compost, fertilizer, and bedding can be used, or the biogas can go in storage tanks where it can go into a CHP unit, which is combined heat and power or cogeneration. It is a simultaneous production of heat and power with a single fuel source such as methane, and then the electricity can be used as heat to go back into the building at the scalder, or the methane can come straight from the storage tanks and be burned as a flame underneath the scalder. This is a step. The biomass or offal will go into the digester and undergo 4 stages: hydrolysis, acidogenesis, acetogenesis, and methanogenesis. And then when that's done, the biogas or methane will come out and be used as energy. Bacteria is one of the key roles in the methane digester. It is what makes it work. Each stage has a little bit different bacteria. In early stages, such as hydrolysis, the materials inside are broken down, but as the stages go on, such as in acetogenesis and methanogenesis, materials are built back up. In hydrolysis, carbohydrates, fats, and proteins are broken down. In acetogenesis, sugars, fatty acids, and amino acids come from the carbohydrates, fats, and proteins. In acetogenesis, carbonic acids, alcohols, hydrogen, carbon dioxide, and ammonia will come from the sugars, fatty acids, and amino acids. And then the beginning of methanogenesis, you will get acetic acid, carbon dioxide, and hydrogen. And then by the end, you will get methane and carbon dioxide. This is a table of the raw biogas that will come out of the methane digester. About 50 to 75% of it will be methane, 25 to 50% will be carbon dioxide, 0 to 10% will be nitrogen, 0 to 1% will be hydrogen, 0 to 3% will be hydrogen sulfide, which is the smelly part, and there shouldn't be any oxygen in there because it is an anaerobic digester, and it'd be different.
Nelson Shine Produce has most of their bird production in May to December. They process about 2,000 birds a week, and each bird has 1.67 pounds of offal. They approximately have 1.5 tons of offal per week. This bell curve shows that in January and December, their processing has slowed greatly, but then in May and June, it increases. Assuming that 180 cubic meters of methane are per ton of offal, we got that from biogasrenewableenergyinfo.com. They have 274.5 cubic meters of methane produced per week. There are 2,550 BTUs of propane per cubic foot, with 52.02 meters cubed propane times density of the propane. They get the mass of the propane, which is 97.9 pounds or kilograms, and the density of propane liquid, which is 4.11 pounds per gallon. They save about 52.64 gallons of propane by using a methane digester per week, and the assuming cost of propane, which is $1.75 per gallon, they save $368.51 per month by using a methane digester. In 2014 and 15, Nelson Shine Produce energy cost averaged $900 to $1,200 per month. With that 180 cubic meters of methane per ton of offal, they get 5 kilowatt hours per cubic meter of usable methane. 900 kilowatt hours per ton of offal, which is $90, times the 1.5 tons of offal, they get $135 of potential electricity from methane per week, or $540 per month.
Here are some methane digesters that we think could work for Nelson Shine Produce: covered lagoon type, fixed dome, floating drum type, and plug flow. We picked these because they are able to be used in a small scale situation such as Nelson Shine Produce. It's a relatively low cost in maintenance, and it would be used for batch processing. Covered lagoon system is sealed with a flexible cover. Methane is recovered and piped into the combustion device. Complete Mix is an enclosed heated tank with mechanical hydraulic or gas mixing system, best when there is some dilution of the excreted manure with water. Floating drum is a cylindrical dome-shaped digester and a moving floating gas holder or drum. Plug flow can operate at mesophilic or thermophilic temperature. Its retention time is 15 to 20 days. It's usually only used on dairy farms where scraping is present. Temperature is important because you need the bacteria present, and if you don't have it at the right temperatures, right warmth, bacteria won't grow. And the solid content is also important because too much solid content will plug the digesters, and when they're plugged, you won't be able to make methane because it'll be stuck. These are the different types of temperatures. Psychrophilic is the lowest methane can be made at 68 degrees. Mesophilic is 95 to 105, and then thermophilic is 125 to 140. Poultry offal has a solid content of 14%, which is just right for the 4 digesters we mentioned earlier, and manure has solid content under 10%. We recommend Nelson Shine Produce goes with the plug flow digester using batch processing. We recommend they go with the design from the University of Maryland because it can handle higher solid content. They go with the polyethylene material so they won't corrode away as easily. It's low cost. They do batch processing. It's a small scale digester, then do mesophilic temperature for this temperate region. For consideration, there's a solar heated high tunnel. There's still ongoing research on this. You would put the digester in the solar heated high tunnel, and that's how you'd get your heat to grow the bacteria instead of having to pay and all the energy.
We absolutely think that the Nelsons should build an anaerobic digester for the environment and for their business. We think it will work. The next step would be to calculate the cost. In other countries, they are being put in for about $100, but in the United States, there are only examples of large anaerobic digesters for millions of dollars. The Nelsons can use Egg Star Calculator to determine cost. Amelia is handing out a resource where we got this website from. Another step we think the Nelsons should take would be to talk to faculty at the U of M Regional Sustainable Development Partnership so they can help him design a model for an anaerobic digester that would fit his farm. We also think that they should look into permitting. These are steps that we took in our project. Any questions?
Hi, I'm Robin Copel with Jenny-O Turkey Store. Just a quick question maybe on the space constraints with maybe each type that you talked about.
A few of them could be a little bigger, more space consuming, and a few could be smaller. The plug foat that we recommended was a nice smaller one that would be nice for the Nelson Shine Produce Farm.
For every 1 foot wide, it's 5 feet long. It's a 5-to-1 ratio.
I have a question. Adam Burr with Minnesota Corn Growers. I have a question about the ease of operation with the digester that you're proposing. The one digester that I was exposed to seemed like it required almost a full-time technician on the farm to operate it. How's the technology evolved as far as ease of use?
If he uses this methane for propane, it will be easier to it can combust easier. If he uses it for electricity, it will require a generator, which will cause a lot of maintenance. So if he uses it for propane, it will be nice.
Minnesota Corn Growers. I may have missed this, but you were talking about the types of potential digesters, and if I understood you correctly, there really weren't models in the United States because all of them were so big and so expensive. Excuse me. But you did mention much less expensive ones, I believe, in China for in the neighborhood of $100. How do those types of digesters relate to the types of recommendations that you had? Are they similar? Are they the same? Are they totally different?
They're pretty similar to the ones here. They're basically the same. It's just over there they have government funding, where over here we don't have government funding.
So you're saying that a $100 digester there is a $1 million digester here, is that more or less? Okay.
I'm just curious if you could tell us a little bit more about your presentations that you've done outside to different organizations and how it was received, and then if you have visited with neighbors about putting in a digester and how their feelings were.
We did present to Lakes Printing in Brainerd, and we presented to Hunt Utilities campus. They both thought this was a good idea. But we haven't talked to any neighbors around the farm about this project.
We also consulted with Leo Wessler. He's a mechanical engineer at a company called C4.
Thank you for taking the time to listen to us. We had a lot of fun.